Good morning, students. In the last session, we saw the example based on the similarity lesson, that is first lesson, which is based on the parallel line concept, BPT theorem, converse of BPT theorem, angle bisector theorem and its converse. The sixth example from 1.2 is solved. Now in this session, I am going to explain you the remaining examples. Now students, see the first question number 7. In the adjoining figure, if you are observing that what is given here, AB is parallel to DC, which is parallel to EF or FE. Then find X and AE. We have to find out this X as well as we have to find out AE. If you find out X, then 12 plus 6 is equal to your AE. So how to find out X? All of you know that the three parallel line. If this three parallel line and two transversal are there, then the transversal divide both the line which in a equal proportion, and by the property of three parallel line, what you can write down, BD upon DF is equal to AC upon C. So BD upon DF is equal to AC upon C. Therefore 8 upon 4 is equal to 12 upon X. So X is equal to this 12, you have to shift this side, you will get X is equal to 6. So now this is 12, this is 6. ACE, they are the collinear, therefore A is equal to AC plus of C. So AC is 12, 12 plus of 6, that is equal to 18, and therefore X is equal to 6 and A is equal to 18 unit. Next, now in the triangle LMN, this LT is an angle bisector. It is given in the diagram because MT bisect the angle LMN, and in a question also it is given. If LM is equal to 6, MN is equal to 10 and TN is equal to 8, LT we have to find out by the angle bisector. Which property we have to use here? Angle bisector theorem of a triangle. Listen, if you not mention this 2 mark question, sometimes examiner will deduct your 1 marks, because by which property you are writing this, that is very important in geometry. That's why always I am saying you have to learn the theorem. If you don't know theorem, you can't solve the problem. If you not mention in the answer by which property, by which theorem you are solving, then you will not get the marks. Now see how to write, and these steps are compulsory. Related with this one step you can deduct, but this first, second, this third and this last, these 4 steps are compulsory. Half of marks each you will get. Now in the triangle LMN, RAMT is the bisect of angle LMN, and therefore by the angle bisector theorem, LM upon MN is equal to LT upon TN, because I start from L. LM upon MN is equal to LT upon TN, and therefore by substituting the values 6 upon 10 is equal to LT into 8, this 8 shift towards this, LT is equal to 6 into 8 divided by 10, so you will get LT is equal to 4.8. Understood? So by the property of angle bisector of a triangle, we solve this. Same, see diagram. If you can see the diagram, now you can easily find out in what we have to find out. We have to find out the value of X. See the question. In the triangle ABC, BD is a bisector of angle ABC. If AB is X, BC is equal to X plus 5, AD is X minus 2 and DC is equal to X plus 2. Then you have to find out the value of X. So by the property of angle bisector theorem, what we can write? AB upon BC is equal to AD upon DC. AB upon BC is equal to AD upon DC. So this is division is there, it's not working. So X upon X plus 5, X upon X plus 5 is equal to X minus 2 upon X plus 2. So by shifting this X plus 2 into X and this X plus 5 this side, you will get X square plus 2X, and here X square plus of 5X minus of 2X minus of 10, this X square cancel out, 2X is equal to 5X minus 2X, 3X minus of 10. So 2X minus 3X, or you can shift this 2X this side and minus 10 this side, you will get X is equal to 10. Next question. In the adjoining figure, X is any point in the interior of a triangle. This is a point which is interior of a triangle. So point X is joined the vertices of a triangle. Segment PQ is parallel to D. Then QR is parallel to ER. Then EF is parallel to DF. Now in the blank, prove that we have to these two lines are parallel. We have to prove that PR also parallel to DF. Very simple. In the triangle XDE, PQ is parallel to D. If a line parallel to the one side of a triangle, then it divides that remaining side in a equal proportion. So by the basic proportionality theorem, we can write XP upon PD is equal to XQ upon QE. This is equation first. Second, in triangle XEF, QR is parallel to EF. And therefore XQ upon QE is equal to XR upon RF. So XQ upon Q is common. So what we can say? From first and second, XP upon PD is equal to XR upon RF. And therefore from first and second, by the converse, if the side divides the two sides of a triangle in equal proportion, then that side is parallel to the third side of a triangle, and this is the converse of basic proportionality theorem. We can say that this PR is parallel to DF. Understood? So both the theorem we use in the one question this. Now the next 11. In the triangle ABC, ray BD is a bisect, which BD is a bisect angle ABC, and ray CE is a bisect of angle ACE. If AB is equal to AC, then prove that ED is parallel to BC. Very simple concept. We have to use here property of angle bisector. Now listen, in the triangle ABC, ray BD is bisect. So we can write AB upon BC is equal to AD upon DC. AB upon BC, BD is a bisector. AB upon BC is equal to AE upon EB. AE upon EB. And AC upon CB is equal to AE upon EB. So from first and second, what you can say? The property of angle bisector, AB is equal to AC. It is given AB is equal to AC. So this AB is equal to AC. Therefore, this is wrong because we have to write AB upon BC is equal to, this is wrong. What will come here? By the angle bisector theorem, what will come here? AB upon BC is equal to AD upon DC. And therefore, from first and second, AB upon BC is equal to AE upon EB also. And AD upon DC is equal to AE upon EB. And therefore, ED is parallel. If AE upon EB is equal to AD upon DC, and therefore means if the side divides the two side of a triangle in equal proportion, then this side is a parallel to the third side, and therefore AD is parallel to the BC, and this is by the converse BPT. This is wrong. Again I am saying because if angle ABC is BD is a angle bisector, so by the angle bisector what ratio will come here? AB upon BC is equal to AD upon DC. Okay, other things are correct. So this we have to stop here. This all question of 1.2 you have to complete in your notebook. Learn it, study it well, all the 4 theorems, and if doubts are there you can ask me in the doubt session. Thank you, students.